Section 4.7, we start talking about uses of isosceles and equilateral triangles. Our essential question is, what is special about isosceles and equilateral triangles? There are a couple different theorems and a couple of things we can prove and use with isosceles triangles and equilateral triangles that we cannot do with just any old triangle. So let's start with some definitions. The legs are the two congruent sides of an isosceles triangle. The vertex is the angle formed by the legs. The base is the side of an isosceles triangle that is not a leg. And the base angles are the two angles that are adjacent to the base. Of an isosceles triangle. So I'm going to draw a little picture over here, which might help you. So an isosceles triangle, just a little review, is a triangle that has two congruent sides. Okay. The legs are the congruent sides, so we have a leg here and a leg over here. The vertex angle is the angle formed by the legs. So this angle right here is the vertex angle. Right? The base is the side of an isosceles triangle that is not a leg. So down here is the base. Right? And then the base angles are the ones that are adjacent to the base. So right here and right here, these are the base angles. Okay, so there's two legs, there's a base, there's a vertex angle, and there's base angles. Right, and then we have a couple theorems. The base angle theorem says that if two sides of a triangle are congruent, then the angles opposite of them are also congruent. So basically, if AB and AC are congruent, then angle B is congruent to angle C. Okay, and this one, the opposite angles are congruent. So opposite this side and opposite this side, those angles are congruent to each other. And theorem 4.8 is the converse. It says if two angles of a triangle are congruent, then the two sides are congruent. So if angle B is congruent to angle C, the opposite sides are going to be congruent. So this means that AB is congruent to segment AC. The opposite sides, these two green sides, would also be congruent. So two congruent sides means two congruent angles. Okay, and example 1, it says to apply the base angles theorem if triangle FGH, so we have triangle FGH, and they tell us that FH is congruent to GH. So this is what our picture looks like. Name two congruent angles. So what is opposite side FH? Angle G. And what is opposite side GH? Opposite GH is angle F. So angle G and angle F are going to be congruent because the two opposite sides are congruent, so those two angles must be congruent. Then we have a corollary to the base angles theorem. It says, if a triangle is equilateral, then it's also equiangular. So basically, if all of the sides are the same, then all of the angles are the same. Likewise, if a triangle is equiangular, then it's also equilateral. So basically, three congruent angles means three congruent sides, or three congruent sides means three congruent angles. Okay, so example 2. Find the measure of angle R, angle S, and angle T. Okay, so if you look at this picture, notice all three sides are 3 meters. So how many congruent sides do we have? We have 3 congruent sides. So if we have 3 congruent sides, that means that each of these angles is also going to be congruent. So it's X, X, and X. So 3 congruent angles. So if we want to find the measures of angle R, angle S, and angle T, we would add them up. X plus X plus X. And remember, all 3 angles in a triangle add up to 180. So X plus X plus X equals 180. So we would get 3X equals 180. And then we would solve for X by dividing by 3. So you'd end up with X equals 60. So if X is 60, that means angle R equals 60 degrees, angle S equals 60 degrees, and angle T equals 60 degrees. So angle R, angle S, and angle T are all 60 degrees. And 60 plus 60 plus 60 is 180. So that's why that works out. Example 3. It says, use the isosceles and equilateral triangles. Find the values of X and Y. So if you look over here, the triangle on the right has 2 congruent angles. I'm talking about this triangle over here, the blue one. Okay? So if the 2 angles are congruent, that means the opposite 2 sides are also congruent. So if one opposite side is 8, this opposite side over here is also 8. So X must equal 8. We also have this red triangle. This red triangle has 2 congruent angles, 2 green ones there. So the opposite sides are also going to be congruent. So this means that 2y equals X. Okay, and up here we said that X equals 8. So 2y equals 8. And we're going to solve this for y. So we divide by 2 to get y equals 4. And we use the isosceles triangles theorem there. The opposite sides are congruent because of the 2 angles being congruent. Okay, example 4. Find the value of X and Y in the given figure. All right, so if we look at this, they tell us that those 2 sides are congruent. So let's start with finding Y. We know that those 2 sides are equal, so we know that 3y minus 3 is equal to 12. So we solve this. We would add 3 to get 3y equals 15. And then we divide by 3. Y equals 5. All right? So we get y equals 5. Now, since we have 2 congruent sides, right, this side and this side are congruent, we also have 2 congruent angles. So which angles are congruent? The angles that are across from those sides. So that means that this angle and this angle would be equal because they are opposite the 2 congruent sides. So both of these angles will be the same, so they're both 2x. So how can we solve for x? Well, remember, all 3 angles of a triangle add up to 180, so we know that 2x plus 2x plus 40 equals 180. 2x plus 2x is 4x. Then we minus 40 to get 4x equals 140. And then divide by 4. X equals 140 divided by 4 is, let me quick get the calculator out. Oh, let's screw this one up. 140 divided by 4 is 35. So we were able to solve for x and y. Okay, and then we have a checkpoint, the last part here. Use the figure at the right to answer the following questions. If FH is congruent to FJ, so we have this big triangle, and they tell us that FH is equal to FJ. So those two red lines are congruent. What that means is the opposite angles are congruent. So it would be those two angles. So it would be angle H is congruent to angle J. And then they tell us if triangle FGK, so let's make that a green triangle, F to G to K, is equilateral or equiangular. That means all the angles are equal. Then FG, and FG is 15, so this is 15. How big is GK? So if this green triangle is equiangular, it also means it's equilateral. So all the sides are 15. So that means GK is 15. Okay. So that is it for the section on isosceles triangles and equilateral triangles. If you have questions, I will see you in class.